Greetings, my fellow descendants. I go by the name of K Pro, and I'm back with yet another interesting tutorial on mathematics. As per usual, you guys know that I strive to simplify and make mathematics and physical science easier and interesting for you guys to enjoy when you're writing your prelims and your final exam, so that everybody gets distinctions. Remember, we're trying to eradicate that concept that mathematics is actually difficult. So guys, I know I've been gone for a while. I know I've not been around. It's mainly because you guys are on holiday and I did not want to interrupt you guys on your vacations. And yeah, I heard that there's no longer masks, so I know you guys have been partying hard and not even checking your physics book or whatever. Okay guys, so we're going to start with the tutorial. I just want to sneak in a few motivational words with you guys. Guys, it's July right now. Okay guys, and I know most of you want to get distinctions. If you want to get a distinction, you have to start building that distinction right now. You cannot get a distinction with a preparation duration of like 2 weeks, guys. We have to start now. Okay guys, we can do this. We have to start now, understanding each and every concept, understanding each and every video that I'm putting out, and seeing how it can work for you guys. Practice makes perfect, guys, okay? You can get that distinction. It starts now. You see, a reflection will be what you're going to get in your prelims, and that should guide you if your strategy is working or not, right? So you're going to sit down and formulate a new strategy now that the schools have reopened, and then see if that strategy is going to work for you in the prelims. If your prelims you do bad, it means that you have to change the strategy, okay, guys? So let's get working. Alright, let's get working. Alright, so today I'm going to be talking about something that you guys struggle with, and it's actually 3 marks. Let's go ahead and check it out, guys. Right, here we go. I don't know what you guys call it. Do you call it congruency or similarity? Yeah, but there's a question in each and every paper too. This is DBE November 2019, right there. There's always a question like this that will come up, and you will have to actually give similarity, prove that these angles are equal, prove a cyclic quad, and so forth, okay? This is usually out of 25, right? But now the purpose of this video is not actually to help you get this 25, because most of you guys are well equipped and have a lot of knowledge regarding this part, right? But now there's a question or two that you guys are missing out every time you are writing your exams. I was browsing through my Facebook the other day, and I saw a learner complaining about 10.2.2c. So I highlighted that question because it's a very easy question, and I was so sad. So I decided that I'm going to explain that question, and I'm also going to explain the first question right there, which is write down the 3 other angles each equal to x. I might help somebody out. Right. Now guys, let's go back to my first video, Euclidean Geometry Part 1. What did I say? Now let's look at the rules that I said in my previous video, right? So in my previous video of Euclid, I told you guys that the first thing that I want you guys to do when you look at Euclidean geometry is that when you approach a question that is like this, I want you to forget about the questions, right? I want you to read the Bible. Remember, we call this a Bible, right? I want you to read the Bible and pretend that there is no questions at all. That's the only way you are going to conquer Euclidean geometry, right? That's what I told you the last time. So what do we do? I mean, are we going to pretend, right? We're going to pretend, right? We are going to pretend like there is no cues. Okay, what I usually advise my descendants, for those of you who just joined us, is that every time I say something that is fruitful to you, you should just write it down, because my handwriting digital is very, very bad. Okay, guys, if it's bad even in real life, but that's a story for another day, right? So we're going to pretend like there is no cues. Cues means questions, right? So that's what I said in the previous Euclidean geometry video part 1, where we were dealing with angle sizes, right? You should check it out. Okay, guys. So now let's go back to this, right? Now you're probably wondering, how is this pretending going to help us? The pretense, right? Guys, we're going to read our Bible first, right? We read our Bible, and then whatever we are given in our Bible, we're going to plug that information in our diagram. What they usually do in paper 2 is that your answer book is going to have these shapes. So basically, in your question paper, the question will be like this, and even in your answer book, you'll be given a shape again. Do you know what that shape is for? It's for you to construct and also plug in your information. That paper must be dirty from you plugging out information and angles and sizes and everything. Do not leave it blank in your answer book. The only one that you should leave blank is the one in the question paper. But in your answer book, you are going to be given the exact same structure, and then you'll be given a space to answer the question. Make sure that you dirty that thing as much as possible, plotting in angles, because I think markers also look at that. And let's just say you got something wrong, but you plugged in the right degree or whatever or size, they're going to give you marks to actually look at that. And sometimes if you are proving as well, what happens is that you'll have to construct, and they're going to look at your answer book, not your question paper in terms of construction. Remember, your question paper remains, right? So when you construct on those shapes that you're given, guys. Take note of that, guys. It's very important. Now, let's go back to what I was saying. Remember, we are going to act like we don't know that there is a question down there. Now, they're saying to us in the diagram, ST and VT are the tangents. Okay, guys, before I continue, you are probably sitting out there in your house, you're like, oh, this thing is difficult. I don't understand this. Okay, please do this for me. Just open up your mind and tell yourself, this thing is easy. Then just start listening to me, okay? I'm going to try and make this thing as easy as possible. Remember, I'm only explaining 2 questions here because the rest were explained in the previous video, right? So guys, open up your mind. Don't think this is difficult. Listen attentively. Take notes, right? So now they're saying to us, ST and VT are tangents to the circle. The word tangents, right? In my previous video, I told you that when you see a tangent, already Dr. CPT applies. And then what is the T? The T is a tangent. A tangent gives birth to what? A Chord Theorem. So we're going to use our famous formula now. Alright, let me just solve that real quick. I'm sorry for that. Alright, we are going to use our famous formula, which I call Dr. CPT. I think it would be fruitful for you to go back to the previous video so that you can understand this video better. We're going to use what we call Dr. CPT to solve this. Everything that is included in geometry, guys, I highly recommend that you use Dr. CPT, okay, guys? It's much more easier and much more simpler, right? So we're going to have Dr. CPT, guys, okay? Oh, I forgot that I usually use blue for math and red for physics. My bad. No wonder the application stopped. Okay. Now, you know very well that D is for diameter, right? I explained these already, so I'm not going to repeat. This is the radius. And then the C is a cyclic quad, right? Cyclic. I'm not going to write it perfectly. It's a cyclic quad. The P is parallel lines, right? Parallel lines. And then your T. Now this is where the tangent comes in. Your T stands for the tangent. Now guys, what do we know when we see the tangent? I explained this in the previous video. What do we know when we see the tangent? When we see the tangent, guys, we know that there's going to be a tan chord. I hope my spelling will be correct. Tan chord theorem, okay? My bad. There's going to be a tan chord theorem. Okay, guys? We know very well that it's going to be a tan chord theorem. Okay, guys, so we can go back to our worksheet over there and check it out. Right. So now they're telling us ST right there. There are tangents, right? And VT, there are tangents, which is correct. Absolutely correct. Now, what do you know about the tan chord theorem? It only applies in the presence of what? Okay, guys. So you must know how the tan chord theorem works, right? If there's a tangent, right, and there is maybe a cyclic chord in the circle, right? So already, if you already watched my other video, we are going to start by saying, remember, we don't know what the questions are. Here is our tangent ST. Which angle can ST give us? We have to think about that. Look at this. We have X right there, right? Look at this part, S2. S2, we have X, guys, okay? Please listen attentively. We have X, right? Chord Theorem says this angle that is here, right? Am I lying? It says to me that this angle that is here must be equal to the angle that is here by R. Am I mistaken? If I am, I stand to be corrected, okay? I am told that angle S2 should be equal to angle R. The reason is Chord Theorem, okay? So I'm told that S2, guys, I did not just come up with these numbers, these things. These are the things that I taught in the previous video, the Chord Theorem, and I explained everything. So right now we're just flowing, because this is the continuation, right? So angle S2 should be equal to R, angle R. Why? That's the Chord Theorem, right? Chord Theorem. Don't mind my spelling, guys. Spelling does not even count for a mark in mathematics. Right, guys? So now we have this. Okay? We have this. I'm going to try and plot. I told you I'm going to try and plot in each and every piece of information that I get from my Bible here, right? Great. Now, they are telling me that VT is also a tangent. I'm thinking of what I'm thinking. There must be a Chord Theorem somewhere. So we go to V3. My V3 must be equal to what? According to you. Think about it. My V3 should be equal to my, I stand to be corrected as well because, damn, maths is a problem. Right. My V3, which is coming in like this, should be my R. I stand to be corrected, guys, okay? Should V3 be my R? V3 should be equal to my R. If I might be mistaken, it might be S1, okay? You never know these things, okay? But I think, okay, yeah. What's happening here is, yeah, it makes sense, Yeah, my V3, because it's coming off from T to V right there, right? It's VT. What do we know about the Chord Theorem, guys? Now, this is the most important part that you have to understand. They're saying that this angle, right, should be equal to which angle? That angle. So my V3 will also be equal to R, if I am not mistaken, right? Remember that word, if I'm not mistaken. So V3 must also be equal to R. Same reason, okay, guys? Same reason. I hope I'm not mistaken. Okay, I hope I'm not mistaken. Right. So now we know that what they gave us in this Bible, we've already used this and this to our advantage. Right? We never even looked at the questions, guys. Bear with me. Be patient. Mathematics requires patience. And everybody makes mistakes in mathematics. No one is perfect. Right. Now, we were told something, guys. We are told that S2 is equal to X. So if S2 is equal to X, let's go back to our notes. S2 is equal to X. This S2 is equal to X. Right, guys? Right. Which means R is also equal to X, guys, because they are equal. So R is also equal to X. Right? And if R is equal to X, which means V3 is also equal to X. Can you see how this thing is now interlinked? Now everything is starting to make sense. How many angles are equal to X now? S2 is equal to X, R is equal to X, and V3 is equal to X. Now we've just solved a big puzzle at the same time. By just doing what? By just reading the Bible and understanding the concept of the Bible and applying what I taught you in the previous video, which is Dr. CPT. Right, guys. Now, we know that R is equal to X here. We know that V3 is equal to X there. Now, let's read the next statement. R is a point on the circle, right? And W is a point on the chord. RSWT is parallel to RV. WT is parallel to RV. This and this, they are parallel. Okay, guys, when you see parallel lines, now they're giving us a hint. When you see parallel lines right there, Dr. CPT, what do we know? We are going to have fun, right? What is this fun happening here? We know that if there is there, and this is there, and this is there, we are going to have fun, guys, okay? So now we have to look at something right now. Which shape can you see from these parallel lines right here? Guys, if you don't understand the parallel lines, go back to my previous video of Euclidean Geometry Part 1. Okay, we see that WT is parallel to RV. Which shape does it form? Can we form an F here? Let's see. No, we can't form an F, right? But we can form a Z or an N. Let's see if I have an N on my Dr. CPT. Yeah, there we go there. And what does this say? It says this angle must be equal to that angle, right? So let's see what's happening now. So, what do you know now? We are being told that angle W2 is equals to V1. Okay, guys? W2 is equals to V1, right? But we don't know what the letter is, whether it's an X or what. Ne? But we know, let's note it down. We know that W2 is equals to V1. What's the reason, guys? This, okay, we call this corresponding angles, we call this co-interior angles, and we call this alternate angles. So that's our reason. Alternate angles. Guys, this is grade 9 knowledge. Now I want to highlight another thing that I always highlight when I'm teaching this section. Guys, do not form your own Z out of the parallel lines. The Z, the F, and the U only apply within the parallel lines, guys. Okay, guys? So there is no way you guys can say TS and RV, they are parallel, therefore V1 and V2, they are equal to S2. Never, guys. There is no parallel lines there. This only applies in the presence of parallel lines within two lines, guys. I hope it makes sense. I even highlighted this in the previous video. Okay, guys. Now, I'm glad that we are having an understanding. So far we know that W2 and V1, they are equal, according to the statement. And then there's an intersection, SV at K. SV at K. Okay, as you can see, there's an intersection there. Right. The Bible, we are done with the Bible. It told us what we have to know. Right? We know what we know. We know what's happening in regards to the Bible, right? But we have to try and manipulate the information that we took down in order for us to find more angles. Right, guys? How do we do that? We already found 3 angles, right? So if you have a pen and paper there and you drew this shape, what I want you to do is go to the diagram and start plotting in that S2 is equals to X, which means now your R is also equals to X and your V2 is equals to X. How is that going to help you? You are going to try and visualize this and see if you can't find any other angles using what you have there. So if you have S2 is equals to X, we'll start trying to find other missing loopholes. Do you understand what I'm saying? So let's see. We're trying to solve for this thing without, let's see which other angles we can find, if possible. If we can't, then, right. And note, guys, I do not prepare for these tutorials. I do not do my research or homework and start practicing and then come and teach you something that I practiced. No, guys. I just wake up today and see that there's a problem in this particular question. Then I just get my laptop and I start recording a tutorial, right? Because I have knowledge with these things. And in most cases, all these questions, I'm solving them right here on the tutorial, right? I've solved these maybe 1 year ago, 2 years ago, but now I don't remember them. So I don't prepare for these tutorials at all. Just to show you that this is just a natural thing. Alright, guys. So if we have X here by R, and we were told that R is a point on the circle, right? And we were not told, guys, do not make up your own conclusions, right? We were not told that we have a cyclic quad, right? So therefore, I cannot use anything related to a cyclic quad to solve this question. Okay, guys, I cannot do that, right? However, I was wrong about something. In terms of parallel lines, I want us to look at something. F, we do have F there. The corresponding angle, I want you guys to look at WT and RV, right guys? And then look at RS. Can you see that from S to R and R to V, there's an F there? Can you see that? So that means, if you're paying attention, you'll see that W, let me write this properly, W3 is equals to X, right? Okay, let me say W3 is equals to R, and R is also equals to X, which means now W3 is also equals to X. Let's go and look at it properly. Can you see that there's corresponding angles by V, R, W, S, and WT, guys? Okay, so we are told that in corresponding angles, this angle here at the corner and this angle here at the bottom here, they are equal. And we already know that R is equals to X. So W3 will obviously also be equals to X. Right, guys? So we've solved for the missing puzzle. Right? Good. Now, let's see what more can we get. I'm going to try and rub off, right, where is that white color? I'm going to try and rub off all these, the other nonsense that is on top. Okay, guys? Because I was just showing you Dr. CPT, right? Alright, guys. I'm going to try and rub off some of these things so that it can make more sense. Alright. Please make sure that you're taking notes, guys, right? I don't want to rub off this so that I want to show you that this is going to be applicable in the questions. Okay, guys. So, let's see. What else can we find, guys? Now that we know that W3 is X, right? We know that W3 is now X, right? So what can we find? Let's try and find more questions and everything like that. All right. How can we use this angle as well to more of our advantage? Now, I want you to note something that I've learned, right? Once you see an angle, I'm gonna wrap this off very, very soon. I just want to show you something. If you ever have something like this, and there's an angle here, right, guys? Once they draw a curve on top of this angle, just know that this angle is most likely to be an exterior angle. Okay, guys? Exterior angles of a triangle. Okay, guys? I think you know about these, and I taught this in my previous video. Right, guys? So most of you already know what I'm about to say. Let's go. If you can look at this, the X here is drawn with a curve on top. Right? Now that means that in this triangle, there is a possibility that this X is an exterior angle. Right? It's a possibility. It has not been proven yet. Right? However, we can't use that to our advantage. Right? Because there's two unknowns. Right? So let's move right along. Okay? Alright. So we used the parallel lines. Do we have a diameter? No. Do we have a radius? No. Do we have a cyclic quad? We were not informed. We only have parallel lines and the tangent. Alright. I think that's it. If you can find other angles, then do so. But for me, that's it. With all these angles that I've found, that's it. Alright, guys. Now that I've done this and I've used all this information to my advantage, now, here comes the nice part about it. We can go to the questions now. Okay, guys? Let's go to the questions and let's see what they are looking for. In the questions, the first question says, write down with the reasons 3 other angles which are also equals to X. Remember, they only gave us 1. Guys, we already solved this question. Look at this. 3 other angles that are equals to X. R is equals to X, 1 mark. V3 is equals to X, 2 marks. W3 is also equals to X, 3 marks, right? That's 3, ne? We need how many more? We need, they say it's 6 marks, right? Let's see, 6 marks. Do you know what the other 6 marks is for? You guys are very smart. It's for the reasons, guys. Do you remember what the reasons were? Here we say this is equal to this because there is a Chord theorem, 1 mark. We say this is equal to this because of what? Okay, this is equal to, W3 is equal to R because of your alternate angles, which is another mark. And then why is V3 equals to R? Let's go and see. Our V3 is equals to R because of what? Because of the Chord theorem. I should have highlighted it somewhere here, which is the Chord theorem, which is another mark. That's 6 marks. For free, guys. Can you see that the aid of Dr. CPT before you apply any knowledge on a Euclidean geometry diagram is very much important, guys. Always use Dr. CPT because it's going to aid you. Guys, even if a question is difficult, when I have Dr. CPT, I am not going to get anything less than 50% in that question. Why? Because it's guiding me. It's opening up my mind. Just imagine if we had approached all this 6-mark question with our mentality that, okay, they're saying they're looking for 3 other angles. The first thing your brain was going to do was to try and find other angles without even knowing what is happening, without even reading the Bible. The Bible is there to guide us in Euclidean geometry. Hence, I call it the Bible because it has a lot of information that you are not taking note of here. Okay, guys? Right. Now that you have this, remember I said I'm going to do this question and I'm going to do C. Math is nice, guys. Math is magnificent. Alright, guys. Now that you have this 6 marks, now I'm going to show you how to get this 3 marks. What is the question? We know these, so I didn't want to rub off these, but let me rub it off. Let me just rub it off. I hope you guys were taking note of everything that was happening here. Right, guys? Yeah, I believe so. Right? So that I can just erase everything right now. Alright, now the interesting question comes. Remember, guys, what you must know about Euclidean geometry is that the question is built onto each other. So the first question is dependent on the other one. They are not independent questions. They rely on each other. So if you miss the first question, which means if you don't get this 6 marks, your whole 25 marks is gone. Trust me. Don't panic though. Don't panic. We got this. We are all going to try and get distinctions. 75% at least. Right? Okay, guys. Let's believe in ourselves. We can do this. Right, guys. We are going to see now this question C, 10.2.2. This is the question that I saw from Elena on Facebook and I was very much worried. So I thought that you guys might be having similar problems. Right? Hence I named this tutorial congruency because of that question in particular. They're saying to you there's a triangle. Let us go triangle W, if I'm not mistaken. Triangle WRV 1, 2, 3. Triangle TSV, right? Triangle TSV. Okay, guys. My handwriting is bad, very, very naturally, so don't mind it. You guys must just take notes as I'm speaking. Talking. Right. Now, what they are saying here, this is 3 marks, ne? Simple marks, guys. I was offended. There was a question in your junior exam that had 6 marks and it was like this and people failed it. I'm just going to show you how this thing is so easy. There's a free mark here that most people don't know about. Okay, guys. So now I want you to look at something. It really depends on the memo how they are going to mark, but I'm just going to show you. My teacher once told me that this is how you're going to apply this. Number 1 for number 1. Number 2 for number 2. Let's go. Let's number these things. Number 1, 2, 3. 1, 2, 3. Right, guys? So 1 and 1 are twins, guys. Obviously. So this one is going to get married to this one. This one is going to get married to this one. And the V is also going to get married to that one. Do I make sense? W is getting married to T because it's the first ones. Okay, they're the firstborns of the family. These are 2 different. Okay, let me make this simple example. 2 different families. The firstborn, secondborn, thirdborn. Right? The firstborns go for each other. the second bonds go for each other, the third bonds go for each other. This is what is happening here. So how are we going to write this? W must be equals to T. First bond is equals to first bond. Ne? R is just going to be equals to S. Second bond is equals to second bond. Simple. V, this one, it depends on the diagram. Ne? So let's go and check the diagram first before I can make a conclusion. Ne? Let's see, how many V's do we have here? 1, 2, 3. Okay, V is equals to V. Let's go. I'm going to say V is equals to V. Ne? The V is not common, guys, because we have 3 angles within V, right? So there might be V2, V1 here, but we're still going to find out, right? Based on what we calculated previously. Now, this is the basic structure. This is the first thing that you write. Now, listen to me. Your examiners, the moderators, and the markers, they know that most of you know this. So, they are most likely to give out a mark somewhere here, 1 mark or something, okay? If it's 3 marks, right? If this was 6 marks, you are going to get a mark for just doing this, and you'd have 3 over 6 without the reasoning, right? But now they're interested in the reasoning. Okay, guys, they're interested in the reasoning to show that you understood what is happening. Now they're saying, let's look at what we did before. What is familiar here? For me, what is familiar is my R is equals to S. Why? Because previously I did say that my R is equals to S2. Come, let's go and check it out. S2 is equals to R, which is X is equals to R there. Okay, so does it make sense? Great. So what was the reason behind that? It was a Chord theorem. Chord theorem. Okay, guys. There's a Chord theorem. Now, I want you to look at something. What they're going to do here is that they're going to give you a mark for this reason. Okay, guys. They have to, right? So this is what looks familiar to me. I did this. I can recall that man, this looks familiar, man. You see? So now let's see. W is equals to T. How? How can W be equals to T? Kanjani. You understand? Now all these things, which T, basically? Is it T2 or is it T1? What is going on? Right, guys? Now this is where you have to pay careful attention to what you're doing. Okay, how will W and T be equal? And then another one is V and V are equal. Now the question is which V, right? Because we only know T V3 is equals to R. Ne? That's the only thing we know. V3 is equals to R, which means V3 is equals to X. And we also know that W2 is equals to, is it V2? Let me check again. Yeah, it should be equals to, is it V1? I think it's V1. Yeah, according to our calculations, W2 is equals to V1. And do we have the angle for W2? I don't think so. Right? So we have to think about all those things and take them into consideration before we actually answer all these things. Do we have V3? Yes, it's X. Do we have V1? That's the question you should be asking yourself. No, we do not have the actual letter, but we know that it's equal to W2. Right, guys? Right, and then do we have W3? Yes, we have W3. W3 is equals to X. Now, I want to show you something. If we have W3 to be X here, remember I'm doing this spontaneously. I did not prepare. Right. So now if we have this angle being X as well, right there, and we have this angle being X as well, which angle is X between these two? It's V3, which is X right there. And then what else do we have? Let's go back to our diagram. Right, we have W is equals to T according to this. First bond for first bond, right? And we have V is equals to V. I'm trying to resolve the V problem, okay, guys? Right, we have V1, V2, V3. And we know that the W2 must be equals to V1, right? Alright. V1 can also be equals to V1. Alright, V1, W2 and V1 are equal, yes. which means that's this and that's that. But the aim is that if you can find any angle in between these two, that will account for their sizes, and then we are gone. Alright. Be traumatic. The V's. V cannot be common. Okay, let's look at V3 as well. What can you tell about V3? V3 is it's a Chord theorem, and I did say it's equals to R. So V3 is equals to X. V3 is equals to X, and okay, I see what's going on here. All right, V3 is equals to X. All right. Okay, guys, there's something that you have to take note of now. Because I skipped these two questions, there's something that I did not see. Now, because I didn't do this question, which is 10.2.A, we were proving that this thing is a cyclic quad. Once they say prove that this is a cyclic quad, it means that it is a cyclic quad. So now we are told that WSTV is a cyclic quad. Let's write it down. WSTV is a cyclic quad. It's a cyclic, right? It's a cyclic quad. Please write it neatly. I'm bad with my handwriting, but let me try, because it's kind of like squashed. It's a cyclic quad, guys, okay? Try. I'm going to try and write it again. It's a cyclic, right? It's a cyclic quad. Okay, guys. So, now that we know that this is a cyclic quad, how did we find out? It was not in the Bible, guys, okay? The Bible gave us what you had to do, and then it was your job to prove this. And after you prove this, can you see that they depend on each other? By them telling you that you must prove, it means that they are also telling you that this is a cyclic quad. So there's no way you can fail this, because you are told that this part is a cyclic quad. And now that makes our job easier. Why? Because S2 is equals to W2. Why? Because we have what we call opposite angles of a cyclic quad are equal. Now we're going to write this down. W2, this is on the side, okay, is equals to X, right? Why? We're going to say opposite angles of a cyclic quad, or you can just say concyclic, doesn't matter. This word cyclic quad is a problem of a cyclic. Right, guys, please just write that down. W2 is equals to X. The reason is opposite angles of a cyclic quad. Guys, when you're solving for a question like this, also write down these smaller things the way I'm doing on the side. Why? Because if anything is wrong here, they can award you marks for these. Okay, guys. So now we know that W2 is actually X, right? Now that we know that W2 is equals to X, then we know, okay, W2 and V1 are equal. We did say that previously. Now that we know that V1 is equals to, now we know that V1 is equals to W2, which means V1 is also equals to X. So V1 is equals to X. Let me write it down somewhere else, because yeah, I'm going to need this space. So V1 is equals to X, right? What's the reason behind that? The reason is what we call alternate angles. This is one of the angles that we were looking for, but we did not have any size or whatever. Now we know that V1 is equals to X. Now that we know that V3 is also equals to X, and V1 is equals to X, so therefore we can say V1, right, and V3 are equal, right? They are equal. Why? Why are they equal? Because they are both equals to X. And if you wrote this part and this part, they're going to award you marks, because you actually understand what is happening here. Right, guys? So this is what you do. Now we are left with just one. And then we are done with this question. You're probably wondering, why is it 3 marks if it's so difficult? It's not difficult, guys. It just needs you to apply your understanding and use whatever you found on top. Right, guys? W is equals to T. Okay, let's see. How is W related to T? Now, that's the $1 million question that I also want to know. Guys, can you see that this is a cyclic quad as we're told, right? So basically this T1, okay, I taught this in the previous video, but I'm going to try and squash it somewhere here, right? T1 plus W2 must give me 180 degrees. The reason behind this is adjacent angles or opposite angles of a cyclic quad add up to 180. Let's go and look at it, guys. W2 right there and this one, you've probably seen this in class. They add up to 180. You can say they're opposite, you can say they're adjacent, it's fine. Okay, they add up to 180. Right? Now that they add up to 180, we have x here and we have T1 here, right? So, what can we conclude about this? Think about it most prevalently and carefully, right? These two, they add up to 180, right? And even these two, yeah, I think it's this one and this one, they add up to 180. Basically, this one will just be Vx plus V2 is equal to 180, and then V2 will be 180 minus x. Yeah, what's going to happen is now we have something like, is it W2? Yeah, we have something like W2 is equal to T1, and that's just going to give me W2 is equal to X plus T1 is equal to 180, and then T1 will remain as 180 minus X. Okay, guys, 180 minus X. Now, I want you to look at something. It's so easy. Now we know that we are dealing with W2 and T1, right? But now the problem is W2 and T1, they are not equal, guys. They are not equal, right? They are not equal. What is happening here is that they are supplementary, okay? They are supplementary. So, it means now there is something that we are missing, right, guys? However, there is another cyclic quad. Remember, it's either this one, right? And there is another one which is like this. Okay, guys, can you see that? There's another one which is like this there. So, I can say to you, the other one which is like this would be like that and like that. And it would be S1 there and T2, which is impossible. But this will also still be supplementary. Bear with me, please. Alright. This W3 is equals to X. Right? And it works with these ones. And if it's supplementary to these, W3 must also be equals to T2. The issue of T, we have another cyclic quad within these, which is also this one here. Right, guys? Do we know what V2 is, first of all? Yes, we know what V2 is. How do we get V2? We use the cyclic quad within here. And let's look at the cyclic quad that the V2 is within. The V2 is within this cyclic quad, right, guys? And we can tell that it will be 180 minus X, right? When we look at the other, okay, what's happening here, guys, is that the cyclic quads are intertwined. I don't know how can I say this? They are intertwined. There's a lot of cyclic quads in one. Okay, guys, so what you can look at right now is T1 and V2, they're equal. But now we have to deal with something that is related to W, right? And the only way to deal with the W, a bit tricky. Another one is T2 and T3, and then the other version is, alright, the T is actually very confusing. Ouch, here. The T is actually very confusing. Well, right. Probably there's something that I'm missing that I do not see. Probably. WRV. Where is WRV? WRV is isosceles. There's something that I'm probably missing. We dealt with V, I believe. Yes, we dealt with V and all that. It's this one. This cannot be possible. Right? Okay, they are not equal, but they add up to 180. Okay? They add up to 180 degrees. They add up to 180, but they are not equal. We have to find something that is going to be equal. Right. The cyclic quad is so intertwined. I don't see anything. We have W3, which is equal to V3, we have S1 is equal to T2. Is there a way that we can find an angle for S1? Probably that could help us. Okay, guys, we have W3, which is X, and we know that W2 is also X. So if I were to sum up these into a supplementary angle, what would that give me? Because I'm trying to apply each and every possible way to find the answer to this. Alright. That would be X plus X. Plus what? Plus that. And then that's 2X, 180 minus 2X, and that's W1. Alright. We are going to discover the problem just now. Give me a few minutes. Alright. Okay, guys. So what's happening here is we are told that W1 is equals to T, right? W1 is equals to T because they are all of them, they are equals to X. If we can look at W3, which is equals to X, and this one, which is equals to X, and this one must also be equals to X because they're all going to add up to 180. Therefore, they are supplementary. Right, guys? So that now we know that everything here is X, right? If this is X, and then the T also must also be equals to X as well, right? I'm just going to try and find a better way to explain this one. You're right. WTX. Alright. W1 is equals to S. T3 equals to X. T. Alright. T being the whole of V and being what it is right now. Okay, guys. Alright. Don't know what's going on here, but the answer is W is equals to T. And I'm checking out the memo right now. The memo says you would get a mark for just putting out the statement, and then you would get a mark for saying this and putting this as well, and you'd get a mark for this and outlining this, and that will give you, how many marks is this? Yeah, how many marks is this? It's okay, it's 3 marks. Okay, we are not done because we also have to outline that how we proved this, and we are well aware that we're using angles, right? So what I'll do is just put that we're just going to take this whole thing, write it down again, right, and say W R V 1 2 3 T S V, ne? And then you say the reason is this, and you're going to get a mark, ne? Angle, you can just say A, which is angle, and that's going to give you a mark, right? And then I'm just looking at this in terms of the memo right now. You're going to get a mark for highlighting this, and then you're also going to get a mark for the statement on the or the reason for finding this. So this is actually 2 marks, so 1, 2, and you get 3 right there. How many marks was this though? 3 marks. Yeah, and that's it, guys, right? That's it. So this, you are not required to know the reason. Okay, guys? You are not required to know the reason of this according to the memorandum, but you're required to get these. Okay, guys, so you just have to know this, and then as well as the final statement. Okay, guys. Now, all in all, just to wrap up this tutorial, I know it was long because I had to think about the answer for the WT. All in all, guys, this is very simple, right? It just needs you to open up your thinking capacity and take it to a higher level. Okay, guys, it's very, very much easy if you do practicing. I'm one person who just attempts a question. Even right now, this question, I just attempted it out of nowhere. Like, I just chose that, okay, I'm going to go for this question instead. I can always do another one, right? You understand what I'm saying? I'm very spontaneous. So you guys, please try to practice a lot, listen to these tutorials attentively. The aim of the tutorial is not for me to be perfect, but it's actually for you to get the idea of how I'm getting these answers. Okay, guys? So far, I've dealt with these two questions, right? I'm not going to handle the others. They're way too easy because you guys are in Matric and you know how to prove these. Okay, guys. So, guys, never ever lose marks on this question. You always have to get a total here, right, guys? And even on the first question of this. And if you got a total in this, you already have 9 out of 25. I don't know how much percentage that counts for, but I'm pretty sure it's a lot. All right, guys? Right. Okay, guys, before I wrap up this tutorial, guys, please just hit the subscribe button. Tell your friends that I teach, I tutor, I make tutorials, and I help out where I can by simplifying things that people think are difficult in mathematics and physical science. More tutorials are coming each and every day. Just subscribe to my YouTube channel. And if any of you need personal assistance, I'm always going to pin my numbers on the description of the tutorial. Follow us on Facebook as SciMasterZA. Follow us on TikTok as well, SciMasterZA. Instagram, SciMasterZA. We will be hosting tutorials, camps, and everything throughout SA and everything like that very, very much soon. So we might visit your school for a workshop. You never know. If you ever see me at your school, just holler at me and tell me that you saw me on YouTube, okay? Keep on subscribing, guys. That's the only way you guys can show gratitude towards me. Subscribe. Leave comments on anything that I made a mistake on you didn't understand. Just leave comments. And yeah, just interact with me on that level. On the last note, I will be hosting Twitter Spaces. I think next week or next week. So every Thursday, you guys are going to get a chance to talk to me and Lungisinkosi, if possible, and other scientists out there. And we're just going to give you words of motivation. We're going to attempt a few problems, a few things that you guys face, syndromes that you guys have before writing the examination, how to tackle questions, why this method is not working out. We're going to discuss all those things, methods, packages of studying and everything like that. We're going to discuss all those things in the camps and everything. So it will be very wise for you guys to join us for those motivational talks and everything like that. Otherwise, from me, your boy K Pro ATM, I'm out. Enjoy. New tutorial tomorrow. Shout out.